So we're going to take a small break from transformations, or will we, and talk about even and odd functions. All right. You'll see what that means in a bit. So let's start with the definition. And each of these definitions are going to have like two parts to them. Okay. So a function is even if it's symmetric with respect to, and oftentimes we abbreviate with respect to WRT, with respect to the y-axis. That's part one of the definition. Okay, so let's look at some examples of this. Some things that are symmetric with respect to the y-axis. Okay, so if we're looking at x squared, for example, did I say x? I meant y. Symmetric with respect to the y-axis means it's on the same on either side of this blue line. So notice x squared is the same on either side of this blue line. Be careful. Let's see. We could also look at 1 over x squared. Purple graph is the same on either side of the blue line. Absolute value of x. Same on either side, right? It's a reflection. The thing on the right of the blue line is a reflection of the thing on the left of the blue line. These are all even functions. All right. Now notice something. If I reflect this function, if I add a negative here, reflected about the y-axis, nothing changes, right? It's already a reflection, so if I reflect it again, nothing changes. If we look at a parabola and I reflect this parabola about the y-axis, nothing changes. So that's another definition that we have for even and odd functions. That if I reflect this function about the y-axis by adding a negative on the inside, oh no, I'm starting to disappear again. Nothing changes. So a reflection about the y-axis doesn't change the function. Similar definition. A function is odd if it's symmetric with respect to the origin. Now that's a little harder to see. Well, let's look at Desmos. Let's look at some odd functions. X cubed, for example. When I say symmetric about the origin, what I mean is that if we look at the origin, the point 0, 0, if we flip every point about 0, 0, so this reflected across goes down to here. This point reflected across goes down to here. Another way of thinking about it is reflecting it about both axes. If I reflect x cubed across both axes, so add a negative on the outside and a negative on the inside, it's the same. If we put one reflection with another reflection, we get back to the original function. Okay, let's look at another odd function. We could look at 1 over x. This is an odd function. Note, any point on this graph, if we go to the opposite side of the blue point, is still on this graph. Or similarly, we'd use the same logic. If we reflect it one way and then reflect it the other way, if we reflect it both ways, we're the same graph. So that's another way of thinking about odd functions, is if I reflect the function in both ways, across the vertical and across the horizontal, the x and the y-axis, we get the original function back as well. right? So again, this is reflect about or reflect about y-axis is the original graph. And the same thing here, reflecting about both axes is the original graph. So let's do some problems. Example, I don't know what number I'm on. I'm going to pick a random number. Example 5. Are the following even, odd, or neither? And there's two ways of answering each of these, graphically and analytically. Look at y equals x squared plus 2. Let's start by looking at the graph. So y equals x squared plus 2 looks like this. Well, it's certainly not symmetric about the blue dot, right? There's nothing down here. So it's not odd. Is it symmetric across the y-axis? Yeah, it's the same to the right and the left of the y-axis. Okay, so that means it's even. Right? This is symmetric with respect to the y-axis, so it's even. Now, there's another more complicated way you could show that it's even, and that's pretty cool. It's even if this is true. So let's look at f of negative x, right? Another way is if f of negative x equals the original function, it's another way. There's two ways. Graphical, analytical. Let's look at f of negative x. Take the original function, replace all the x's with negative x's, and simplify. Original function, x's are replaced with negative x's. Negative x times negative x is positive x squared. Ah, that is the original function. Right? It's the original function. That's another way of seeing that it's even. Let's do another one. Y equals x plus 2 squared. You might think, Jason, this is just another parabola. Of course, it's even. Let's look at it. X plus 2 squared, this is a function transformation 2 to the left. It's still symmetric around something, but it's certainly not symmetric about the white line. This is not an even function. It's not symmetric about the origin either. This is not symmetric around either. We're going to say this is neither even nor odd. And you can use graphing utilities to check your answers here, or you could do it with the analytical method I showed in the last video. The next one, y equals x cubed plus x. Let's look at that one. Oh wait, x cubed minus x is actually what I want to do. It makes it a little bit more interesting. Let's change the example. So, is it even? There's some symmetry, but it's not the same to the left as it is to the right, right? It's up to the left and it's down to the right. So it's not the same, it's not even, but it is symmetric about the origin, right? If we go to the right and reflect that, we're still on the graph. Go to the right, reflect around the origin, we're still on the graph. Roughly, it's close to 2,5. Reflect that around the origin, it's close to -2, -5. So it is odd. Okay. Symmetric with respect to the origin. So it's odd. Another way of showing it is that negative f of negative x should equal the original function. So if you have negative on the outside, and then plug in a negative on the inside, and this gets a little complicated, which is why I'm not really going to make you do it. This substitution step is a little tricky. But if we simplify, negative x cubed becomes negative x cubed, negative x times negative x times negative x. Distribute the negative right here. Distribute this negative now. You get positive x cubed minus an x, right? That's our original function. This is another way of seeing that it's odd. But you don't have to do it the second way. You can do it graphically with Desmos. All right, and let's do one more. Part D. Y equals 1 over x plus 2x. Look at this one. Well, it's not symmetric. It's not even. It's not symmetric with respect to this white line. But it is symmetric about the origin, right? We reflect it upside down and then left to right. It's symmetric. So this is odd. All right, that's even and odd functions. Let me know if you have any questions, and bye-bye.